Hello students, today the topic of discussion is diagonalization. In our previous video we have discussed about what is eigenvalue and what is eigenvector and how to calculate them. Diagonalization is very much associated with calculating eigenvalues and eigenvectors. That means you have to calculate eigenvalues and eigenvectors, then you have to proceed for diagonalization. So I am going towards an example to make you understand. The very primitive thing what I am trying to say that you know what is a eigenvalue and how you can calculate eigenvector. Now after calculating eigenvalues and eigenvectors, you have to calculate a matrix. We generally call it P matrix. Okay. Now suppose you are having your system matrix A is 2 cross 2. It is a 2 cross 2 matrix. Naturally, you will get two sets of eigenvalues. You will get two sets of eigenvalues, lambda 1 and lambda 2. For each lambda, you will get a set of eigenvector. So that means you will get a eigenvector x1 which will have a value of this, and similarly you will get another value for suppose lambda 2, that is capital X2. It is also having value of x1 and x2. Okay. Now your P matrix, your P matrix is going to composed of with this x1 and x2. So that means your P matrix will be composed of this x1 and x2. Okay. So after getting the P matrix, what you have to get? You have to get the inverse of P matrix. So after getting the P matrix, you have to get the inverse of P matrix. And then if you want to get the diagonalization matrix D, it will be P inverse into system matrix into P. And after that you will get a matrix which is a 2 cross 2 matrix having the diagonal elements as alpha lambda 1 and lambda 2. That means in a diagonal matrix, the diagonals are the eigenvalues of the system matrix A. So we are going to understand this by using a example. I am taking the example for easier understanding. I am taking the example which I have took in the previous case where we are determining the eigenvectors. Okay, the same example I am taking. Okay, so let us take the example. Let us take the A matrix or the system matrix as 4 cross 4 2 3 3. So it is a 2 cross 2 matrix having these values. Now what we know for diagonalization, what is the first step? Step 1 is to find the eigenvalues. Okay, so eigenvalues, find eigenvalues. What is eigenvalue? We know from characteristic equation we can get the eigenvalue. So what is the characteristic equation? It is lambda I minus A equal to 0. So now if you solve this characteristic equation, you will going to get that the value of lambda, it will be two values. Lambda 1 will be suppose 1 and lambda 2 will be suppose 6. Okay, so these will be, if you solve this particular problem, you will get that this 1 and 6 will come. Next, you have to find the eigenvectors. We have discussed how to get the eigenvectors. So, if you take lambda 1, you will get that there is a eigenvector x1 that will be your -2 and 3. Okay, and for lambda 2 you will get the eigenvector x2 that will be your 1 and 1. We have solved it in our previous example up to this. Now we are going to do the P matrix. So what is our P matrix? P matrix is, now, so this was eigenvalues, then step 2 was eigenvector. After that it will be P matrix. Okay, step 3 is P matrix. It will be x1 and x2. So what is x1? x1 is -2 and 3 and x2 is 1, 1. So this is your P matrix. Okay. So next, after getting the P matrix, you have to take the inverse of P. So what is the property of inverse? Inverse means adjoint of P. You have to calculate adjoint of P divided by determinant. So adjoint matrix of P by its determinant. Okay. So now, what is adjoint of P? This is my P matrix. So we know adjoint means we have to get the cofactors, right? So what are the cofactors? If I want to get the adjoint, so for adjoint of P, that means it will have cofactors, suppose P11, P12, P13 and P14. These are the cofactors. How to get the cofactors? Suppose P11. How to get P11? P11 cofactor is having the formula, that is, it will be -1 plus its position, that is first row, first column. So 1 plus 1. Okay. Into the minor. What is the minor? If you just put, if you take the 1 cross 1, that means this first row as well as first column, this is remaining. So P14 is remaining. Sorry, not P14, I'm sorry. This will be P21 and this will be P22. I'm sorry for the mess. Okay, so P22. So what will be the value of this cofactor? P11, the cofactor will be not P22, it will be this value. This value means it will be 1. Okay, so that means what is the value, cofactor, that means P11 will become 1. Similarly, if you go for P12, P12 will be -1 whole to the power 1 plus 2 into, so P12, so the first row and the second column. Okay, so that means if you hide this, what is remaining? The remaining is this one, that means this 3. Okay, so this 3 will be here. So this will be equal to -3. Now I have missed a point. Adjoint means that you have to put a transpose over here. I forgot this, to write the transpose. So next, P21. What will be the value of P21? It will be -1 whole to the power position 2 plus 1 into, now if you hide this, if you hide this and this, what is remaining? If you hide 2, 2 and 1, first one when I am hiding this and this, so now I am hiding root 2 was 1 1 2 1, so this is this one. Okay, so now it is this one, so this will be 1. So now what we are getting? We are getting it is equal to P21 will be equal to -1. Similarly, the last element is P22. So what is the position? -1 to the power 2 plus 2. Okay, into, now if you hide this 2, this 2 2. Okay, so second row and second column. So what is remaining? Second row and second column, then this is the remaining, so that means it will be my -2. Okay, so that means it is becoming P22 is becoming -2. So this matrix is becoming, if I put all those values, this matrix will becoming, first is 1, then is -3, then is -1, and then is -2. This will be transposed. So if we take the transposed of this matrix, what is coming? Coming 1, and here this is -3, and this will be -1, and this will be -2. Okay, so now we got that our matrix, that means adjoint matrix, is equal to this. Okay, so we got our adjoint matrix. Now if we want to get the inverse, what we have to do? We have to get the determinant. So determinant of P matrix. So determinant of P matrix, that means this is my P matrix. So it is becoming, actually it is becoming -2, so it is becoming -5. Okay, so this determinant is becoming -5. So I am going to the next page. So that means I am getting that my determinant delta equal to -5, and my adjoint matrix, adjoint of P matrix, is coming as 1, -1, and -3 and -2. Okay, so now if I want to get P inverse, it will become adjoint divided by -5. So this is -5, and it will be 1 -1 -3 -2. Now if I multiply the negative with all of them, finally it is becoming 1/5 and -1, and all the elements they become positive. So this is my inverse matrix. So this is my P inverse matrix. Now what I have to get? I have to get diagonal matrix, that is P inverse into A into P. So if I write 1/5 -1 1 3 and 2, now what was my A? A was 4 into 4, 2, 3 and 3. And what is the actual P matrix? That was -2, 3, 1 and 1. Okay, now what I am going to do, I am going to just multiply them. So let us start from this side. So first multiply this with this. Okay, so 1 by 5 minus 1132. I am getting that this is minus 8 and 3 2s are 6. So minus 8 plus 6, and this will be minus 6 and plus 9. Okay. Next, this and this. So this is becoming 6. And here also this is becoming 6. So what we are getting? If we simplify, we are getting that this is equal to minus 1, 1, 3, 2. And it will be minus 2 minus plus 3, 6 and 6. Okay. Now what we have to do? We are going to multiply this with this. So 1 by 5, if I multiply this row with this column, minus 2 into minus 1. So it will be plus 2 and plus 3. Okay. Then this is becoming minus 6 plus 6. We multiply this with this. Next, this one with this column. So it is minus 6 and plus 6. In the next half, it is 18 plus 12. Okay. So my answer is coming 1 by 5. This is 5. This is 0. This is 0 and this is 30. Now if you take common, if you take 5 common, it is becoming 1 and 6. Okay, so these are nothing but the values of alpha 1 and alpha 2. So their alpha 1 and alpha 2 are the diagonal elements of this matrix. So in this way, by virtue of this matrix P inverse AP, we can diagonalize a system matrix A, where the diagonal elements will be its eigenvalues. Okay, hope you all understand this topic. Thank you and happy learning.